Okay, in Unit 4, Activity 4, what we're going to look at is parallel circuits. And one thing I would highly suggest is when you do your work or write your test in this unit, you have the rules for parallel and series circuits side by side, because it can get complicated because the rules are different. So where we were splitting up the voltage, we had a total voltage drop in the circuit in the series. Now what we're going to find is that the voltage in the system is equal to the voltage at V1 and at V2. So if you know that you have a 4-volt system, then V1 is going to be 4 volts and V2 is going to be 4 volts. Or if we were told that V1 was 4 volts, we would know that V total is 4 volts and we would know that V2 is 4 volts. Now, I'm going to throw in a quick trick here, and it's just to see if you can catch on what's going on. This is called a mixed circuit. Here we have a series, and here we have parallel. So series means we have things hooked up within the same strand. These are in the same strand. This one here is hooked up in a separate strand. So if you really understand what's going on, you would understand that this circuit gets 4 volts and this circuit gets 4 volts. These two that are on the same circuit would split up into 2 volts and 2 volts. Now, we're not going to go into what are called mixed circuits, but that is what would happen. Be aware, in a parallel circuit, if we start with 4 volts, each separate circuit gets 4 volts. Now, here's the interesting part. Now, amperage is additive. So if we've got the amps in this system and we've got the amps in this system and we add them up, that's our amps total. So there's I1 and there's I2. To get I1, it's going to be voltage over resistance. So it's going to be 4 over 10, which is 0.25. In I2, we're going to have that 4 volts, that is a 4, divided by the 20. So that one is going to be added up to 0.20. So our total amperage is going to be 0.45 amps if we add those two up. Now, finding resistance for parallel circuits is the tricky part, because the formula is 1 over RT equals 1 over R1 plus 1 over R2. I do it a little differently than they do in the content. I'll show you how I do it. You pick your way of doing this. So what I do is I fill in my information. 1 over RT is equal to 1 over 10. So I got my 10 from there. So I better put that that's R1. And plus 1 over R2. And there's my R2. So 1 divided by 10 is 0.1. Just throw that in my calculator. 1 divided by 20 is 0.05. Throw that into my calculator. I've got 0.15. Now I'll go back up here. And what I do is I want my RT on top. So all I do is I put RT over 1. Since these numbers are assumed to be over 1, it's now 1 over 0.15. In other words, take whatever numbers you get here and divide 1 by those numbers, and that will give you your answer. I hope that was clear. I'll go back over that one more time. So we should get an answer of about 6.7 ohms. Take your two resistances, put 1 over those resistances, calculate them, 0.1 plus 0.05, add them together, and divide 1 by that answer. 1 divided by 0.15 is 6.7 ohms. That is how I do resistance. You may want to refer to the content to see how they do it in there. Now, when we do series, this is how we line batteries up. When we're doing parallel, we put the batteries on 2 different circuits. Let's talk about the similarities and differences. If these are 1.5 volt batteries, so there's one 1.5 volt cell or battery, and there's a second one. 1.5 plus 1.5 is 3 volts if we're going in series. If we're going in parallel, you do not add them up. They're only 1.5 volts. So the question is, why would somebody want to have a battery then that is in parallel? The reason you want it is because it lasts longer. It doesn't have as much voltage as this in series, but in parallel, what happens is it lasts longer.